Hello and welcome to Byjus Exam Prep. Welcome to another episode in our knowledge series where we shall be talking about jet streams and the impact that these jet streams have on the weather conditions across. Now, before we begin, first of all, let us know something about these jet streams, what these jet streams actually are. So basically, it was in the 1920s when we had a Japanese scientist, Wasabura Uishi, who stumbled upon the high velocity winds which blew at the upper levels of atmosphere with the help of his simple balloon experiment. At that point of time, people came to know the existence of high velocity winds at a greater altitude. But then, very soon, that was not something which was capitalized. There was not much of a research which was going on in that aspect. And after some time, during the World War II, it was the jet fighter pilots who actually went on a bombing mission from United States to Japan and back. They observed a significant increase as well as reduction in speed while traversing in different directions. For example, these fighter pilots, they found out that while they were moving from the western part of United States to Japan, the planes and the aircrafts, they experienced a reduction in speed. But at the same time, when they were coming from Japan back to United States, they experienced a sudden increase in speed. So that puzzled the climatologists, and they started linking the findings of Uishi with these fighter pilots. And it is after this World War II that the whole world came to know about these high velocity, high altitude winds we refer to as jet streams. So if we take a look at these jet streams, overall, these are very narrow band of very fast moving winds which blow at an altitude of around roughly between 5 to 7 miles from the ground surface, which translates roughly around 7 to 12 kilometers from the ground surface is where we end up finding these jet streams to be in existence. Now, their velocity can be significantly higher. Many of the times in the central portion of these jet streams, the velocity that is attained by the winds can be in the tune of excess of even 300 kilometers per hour. Now, all these jet streams that are formed, that are created, they oftentimes end up shifting with respect to each other. But other than that, another property that they have is a continuous motion from a westward to an eastward direction. So owing to these two properties, that is, first is their motion from west to east and a regular motion from west to east, and the second one is their shift in the north and the south direction. Both these are actually responsible for bringing various different types of weather conditions that we have. But in order to understand that, first of all, very quickly, let us familiarize ourselves regarding where do these jet streams exist across the planet. We do know that these jet streams are in existence, but where exactly? So that is something which is helped by us understanding the tricellular model of atmospheric circulation. Now, as per the general model of atmospheric circulation, we come across the fact that we have three different cells of atmospheric circulation across each of the hemispheres. We have the Hadley cell, the Ferrel cell, as well as the polar cell. Now, if we take a look at the upper atmospheric regions at the transition between these two cells or any of these cells, we find something very interesting. For example, let's say we take the case of the Hadley cell. Now, in the region of Hadley cell, in the upper portion, here we have winds coming in the upper altitude from the region of equator, and simultaneously we have winds which are coming from the region around 60° north. So obviously, these two air masses which are meeting in the upper atmosphere, they will have a significant amount of temperature difference between them. As they will have a temperature difference, that will also end up creating a pressure gradient in that localized region. Because after all, we know that the air having a warmer or a higher temperature has a greater volume, and the air having a lower temperature has got generally a lesser volume. So a difference in temperature induces a kind of a pressure gradient. Now this pressure gradient shall be experienced where? At around 30 degree, roughly around between 25 degree to 40 degree north and south latitude, we do experience this pressure gradient to be in existence. And because of this pressure gradient, the particles of atmosphere, they start moving at an incredibly high speed. And what we have as a result of that is nothing but the jet streams. Similarly, if we analyze the air masses at around the subpolar region, that is between 55 degrees to 65 degree north and south latitude, there we find that polar winds and subtropical winds, they also end up exhibiting a kind of a difference in temperature. So that difference in temperature also ends up creating a pressure gradient and thereby formation of another jet stream. So like this, in each hemisphere, we have the formation of two jet streams. And these jet streams, because they have been created, because they have come in existence due to the air circulation and what we observe in the case of planetary wind system, these jet streams are also what are referred to as permanent jets. So overall, we have two permanent jets in each hemisphere, in the northern as well as the southern hemisphere. What are those two permanent jets? We have the subtropical jet stream in the region between 25 to 40 degree north latitude as well as south latitude. And along with that, we have the polar jet, which is in existence generally in between 55 to 70 degree latitude, both north and south. Now we know one important fact here, and we have noticed one very important detail here. And that detail is that these jet streams come into existence because of the temperature difference. So obviously, when the temperature difference is going to be much stronger, the jet streams are going to be much stronger as a result of that. And when is it that we have a greater temperature difference? During the summer months or during the winter months? So if you compare the temperature observed in the tropical areas and the polar regions in summer as well as in winter months, we end up finding that the temperature difference during the winter months is quite significant, is quite drastic. So that is why the jet streams, generally you will find, they are much stronger and much continuous during the winter season. Why? Because of the greater temperature gradient, you will find that the jets are stronger, and when they are stronger, they end up moving faster as well. When the jets generally start moving at a very high velocity, you generally end up finding the fact that you have the velocity being so high that the jets start moving in a straight line path. But then when their speed slows down quite considerably, they start meandering their way. Just like when you have a river in its mature stage, as its speed reduces, it starts meandering down its path, right? So similarly, when the jets, their speed reduces, when they get weaker, these jets, they start to meander about. So if this is, let's say, the planet, the jets, when they are slower, you will find them to be meandering. And why does that happen? And when does this happen? You will find that the warmer air penetrates further into the colder regions, and the colder air that penetrates further into the warmer regions. Now this influence and this effect that the jet stream has got a significant ramification when it comes to weather conditions. Overall, we have to understand that these jets are basically a kind of a carrier of weather systems. If let's suppose there is a low pressure system which is formed in some location, and as a result of that low pressure, let's say clouds are getting created. So overall, these clouds and the whole convective system can also be carried by these jets. So the fast moving air currents can transport weather systems to a larger distance. This is something which is observed in India as well during the winter season. When you have low pressure extratropical cyclones which develop in the warm waters of the Mediterranean Sea, the cloud system and the convective system which is created by that is transported not only by the westerlies, but the subtropical jet stream carries all that and it hits the Himalayan foothills, and that is what we call as western disturbances. And these western disturbances, they bring much needed rainfall during the winter season across the northern parts of the country. Yes, it does make the winter more colder, but at the same time it is very helpful in sowing of rabi crops such as wheat as well as mustard. Now, this is not the only influence that the jet stream has, that it will carry over the clouds. As was experienced in certain parts of the globe, such as Canada as well as Siberia in the past year, these jet streams, they are also responsible for extraordinary amount of heating, which is oftentimes carried out. And why does that happen? So let us understand that with a kind of a perspective here. So basically, you will observe that here you have fast velocity winds which are moving at an altitude, very high velocity winds. Here the winds are sinking down in an anticyclonic formation, and you have a high pressure system which is present here. Similarly, here you have the low pressure system and the winds are rising up, and these winds eventually shall be carried away in the upper air of divergence. This wind which is rising up shall be carried away by the jet stream. So what happens as a result of that? As a result of that, let's suppose the jet stream is persistent over a particular region for a longer period of time. They will continue to push winds into this high pressure system endlessly. Even though the temperature starts rising quite significantly, ideally that high pressure should get converted into low pressure. But just because the jet streams continue to supply that forceful application of air on the ground, the air hits the ground, creates that high pressure, and whenever we have high pressure, we have lack of rainfall. So this can create very significant and very devastating heat waves, something which Siberia and Canada, they experienced the previous year. But another thing that one has to keep in mind is, oftentimes these jets, they end up isolating these warm air and cold air regions and don't allow them to mix with each other. Because of these jets, the air underneath, that remains in its original position and is unable to cross over. And why is that? That is because if you imagine this to be the ground surface, in the upper air, you have this river of air which is moving, the jet stream. And this jet stream is moving at a very fast rate. So imagine, even if, let's say, air from one side and the air mass from the other side will try to mix with each other, will try to meet with each other, this upper air obstruction won't allow the air masses to meet at all. So this is the reason that many of the times, despite the high temperature, you don't have cold air coming into that region, and the weather starts getting harsher and harsher, especially in the regions such as Europe, especially that too due to global warming and climate change as the temperature is increasing. In the past couple of years and for the past 4 to 5 years, we have been experiencing a very high, unusually high amount of heating. And that is because in the European region, the jets, they form a kind of a wave, and that wave ensures that warmer air is trapped in that region and cold air does not mix with it. This is something which was also referred to as the Omega block in the European nations. Why? Because the jets, they formed a shape like that of the Greek alphabet Omega. And here you had warm air, and this warm air was trapped in between. So obviously the temperature in this region kept on rising up. This continuous rise of temperature was something which was experienced. Now, when we come about and when we talk to jet streams and their impact on Indian climate and Indian weather conditions, jet streams are very vital when it comes to the amount of precipitation and the different climatic conditions experienced by India. We have already seen that during the winter season, the subtropical jet, along with the influence of the westerlies, they end up carrying this low pressure system which develops in the region of Mediterranean all the way to the Himalayan foothills. While it causes significant amount of snowfall in the Himalayan region, but at the same time it brings rainfall in the region of Himachal, Uttarakhand, Punjab, Haryana, Delhi, parts of Uttar Pradesh, parts of northern Bihar, parts of northern West Bengal, and sometime it can also cause rainfall as far east as the Assam plains. So this winter rainfall is important for the agricultural season. But then these jet streams, the subtropical jet, that is directly interrelated with the onset of Indian monsoon. So this subtropical jet which moves in this region, as it encounters the Himalayan foothills or the Himalayan physical barrier, these jets, they get divided into two subparts. One, we have the northern branch, and then we also have the southern branch of this jet stream. As long as we do experience or we do observe the southern branch of jet stream in existence, till that point of time, there will be no onset of monsoon. Regardless of the fact that the moisture bearing winds, they shall approach the Indian coastline. But still, because the upper air obstruction remains, there will be no convection and no cloud formation, and hence no onset of monsoon. This southern branch of the subtropical jet stream, it starts weakening with the onset of the summer season. Eventually, one final day, it completely disappears. And when it does disappear, that is when we have the sudden convection which happens and we observe the onset of monsoon. This is the influence of the permanent jet. But over the Indian subcontinent, we also experience a role of a temporary jet stream. So what are these temporary jets? So these are those jet streams which come into existence for a short duration during a couple of months, and that too over a small part of the globe, not the entirety of the planet. Now, one of these temporary jets, that is tropical easterly jet. Tropical easterly jet. This is a temporary jet stream which comes or gets into formation because of the heating of the Tibetan highlands. Now, as the Tibetan highlands, they get heated up, you have a low pressure which develops here. Winds rise up. The winds, after rising up, they diverge, they spread out in all directions. And one of these upper atmospheric circulation takes the wind southwards and rather from east to west direction, and they end up reinforcing the monsoon winds coming to India. So stronger the tropical easterly jet, more shall be the winds which shall come to the Indian coastline during the monsoon season, and more the winds that come to the Indian coastline during the monsoon season, more rainfall we shall end up receiving. This tropical easterly jet is in existence around 5 degree to 20 degree north latitude, and its general direction of motion is from east to west. But then after crossing the Indian subcontinent and reaching the coastline of Africa, it crosses the equator and sinks in the region of Mascarene High, and that is how it can strengthen the monsoon winds. There is another temporary jet which helps Indian monsoon and influences Indian climate, and that is the Somali jet. Now, this Somali jet stream is also a temporary jet which moves from the region around Horn of Africa in a direction that is west to east. But then it is a low altitude jet as compared to the other ones. It moves at a lower altitude. So that is why many of the times it simply serves as a carrier of the wind systems over the Indian Ocean and the Arabian Sea, thereby dragging more moisture into the Indian subcontinent. So both these jets, that is the tropical easterly jet as well as the Somali jet, if they are stronger, the amount of rainfall received is higher. If for some year or some season they are not strong enough, the climatic influence is that the rainfall received is very, very less. So overall, what we have seen is basically these jet streams having an influence on the weather conditions, not only in terms of significantly increasing the high pressure region, significantly intensifying the low pressure areas, but also carrier of rainfall, cloud systems, then also extension of heat waves as is experienced in certain parts of the globe. So that is all that you need to know about the topic. And now let us take a few of the questions. One question is, do jet streams influence cyclone formation? Absolutely yes. How is that? So if on the ground surface, let's suppose you have a low pressure which can create a cyclone, basically the formation of low pressure means the winds will rise up from here. As the winds are forced up, as the winds they start rising up, the availability of an upper air wind flow ensures that as the winds they reach an altitude, these are easily carried away by the jets, which means what? More winds will rise up to replace that wind or the air parcel which has been taken away, and this process continues, thereby intensifying the low pressure. When the low pressure intensifies, the cyclone becomes much stronger. Gyan Krishna, how are easterly jet streams formed? So Gyan, there are multiple different theories regarding the formation of the easterly jet stream. Few of the theories, they talk about their formation or existence in the region of Vietnam and Southeast Asia. But then later researchers have shown us that this has to do something with the heating of the Tibetan highlands. Because the region of Tibetan highlands, they are at an altitude of around 5 kilometers above the ground mean sea level, right? The altitude is around at 5 kilometers. So, when you have heating of the rocks at this altitude, that will be a very warm condition. Let's suppose the temperature of the Tibetan highlands during the summer season is, let us suppose, around 5 degrees Celsius. But still 5 degrees Celsius temperature at this altitude will be quite high. Even though it is much higher than 5 degrees Celsius, but that can itself be enough reason for leading to a convection of air. And rising air then diverges in the upper atmosphere, and one part of that divergence follows the Kolkata-Hyderabad axis in the upper air, and that moves from a east to west direction. Vanshika Gupta, what is the difference between jet streams and Rossby waves? So the Rossby waves that we see, Rossby wave is a kind of a formation, so to say, regarding how and what is the pattern that the jet streams follow. Because when we talk about these jet streams, these are specific in a way that they observe a kind of a vertical as well as horizontal undulation. So they move in a vertical manner as well, and they move horizontally as well between various different latitudes. So a combination of this vertical as well as horizontal variation in the pattern of these jets, that is what refers to as the Rossby wave. Donald D'Souza, yes, jet streams, they are prevalent almost in the entirety of the planet. Saima, the jet streams, obviously, they cannot stop completely, but then if suppose they have stopped, means the air circulation has stopped, and that would mean a great amount of difference in terms of heat balance and heat distribution across the various parts of the planet, which can never be good. And some parts of the planet will receive excessive amount of heat, and that heat transfer will not take place between various different latitudes. Okay? Ravi Raghuvanshi, the temporary jets that you have, that is tropical easterly, then you have the Somali jet. Their direction is basically decided dependent upon where is it that the temperature difference is experienced. It is a temperature difference between the air parcel at upper altitude, that is what generates the pressure gradient. So if that temperature gradient or the temperature difference points to a west to east direction, there will be the motion in that direction. Regarding the tropical easterly jet, this wind or this air parcel, if you think about it, an air parcel which has risen up in the region of Tibet, it will ideally start bending to its right. Okay? So as it starts bending to its right, what will be its general direction of motion? It will be from east to west. So that is why in tropical easterly jet you observe an east to west direction. Nandini Verma, jet stream and tsunamis, they are completely different phenomena, my friend. Tsunamis are resulted, or tsunamis are experienced because of the sea floor that self starting shaking up. Okay. And last question, Vinay Mandla, which standard book is sufficient for geography? NCRTs of 11th and 12th. Be regular with that. Revise that on a regular basis, and that shall be more than sufficient. Okay. So with that, I end the session here. Hope this was productive enough and some amount of value would have been added here. So that is all from our side today. Thank you for being with us. See you again tomorrow regarding another geography topic of soil conservation as well as soil degradation. Thank you.